Okay, in example 5, we're graphing a vertical shift of the parent function y is equal to the log of base b of x. Vertical shifts of the parent function y is equal to the log of base b of x. So for any constant d, the function f of x, which is equal to the log of base b of x plus d, it shifts the parent function up d units if d is greater than 0. It shifts the parent function down d units if d is less than 0. It has a vertical asymptote where x is equal to 0. Has a domain of 0 to infinity, has a range from negative infinity to positive infinity. So given a logarithmic function, how do we graph the translation? So again, we're going to identify the vertical shift, which is what d represents. We're going to draw the vertical asymptote at x equals 0. We're going to identify 3 key points from the parent function and identify new coordinates for the shifted functions by adding d to the y coordinate. Then label the 3 points and then determine what the domain, the range, and the vertical asymptote is. So for example 5, we're going to sketch a graph of f of x, which is equal to the log of base 3 of x minus 2, alongside its parent function. Include the key points and the asymptotes on the graph, and then state the domain, range, and the asymptote. Now, since the function f of x, which is equal to the log of base 3 of x minus 2, we will notice that d is equal to negative 2. Therefore, since d is less than 0, this means that we'll shift the function down 2 units. The vertical asymptote is located at x equals 0. We're going to consider the 3 key points from the parent function. So we're going to take the y value for this one. We're going to take negative 1 and subtract 2, which is going to give us negative 3. In the second order pair, we're going to take the y value, subtract 2 to get negative 2. And then the third order pair, we're going to take the y value of 1 and subtract 2 to get negative 1. And so if you notice, we have our y value. It changes from negative 1 to negative 3, and the x coordinate stays the same. If you notice, the y value from our parent function goes to negative 2, and again, our x value stays the same. And then for the last point, we have a y value of 1, which just changes to negative 1. So now we have 3, negative 1. So now what we can do is then graph those 3 points. And so then we know that the function is going to still go along the vertical asymptote at x equals 0. And then it's going to be an increasing function.